So, short range wireless communication. Some of the protocols listed in the short range wireless communication. Zigbee. Zigbee is a IEEE 802.15.4 based specification. 802.15.4 based specification wireless protocol that is used to allow smart devices such as light bulbs, sockets, plugs, smart locks, motion sensors, and door sensors to communicate with each other. Physical range is from 10 to 100 meters. Z-Wave is a wireless communications protocol used primarily for residential and commercial building automation, just like Zigbee. The range is from 100 to 800 meters. Another tool called ANT, its range is 100 meters. A medium range wireless communication protocol, LTE advanced and QUIC. Long range wireless communication, MQTT, NB-IoT. And then IoT communication model. We have device to device communication model, device to cloud communication model, device to gateway communication model, backend data sharing communication model. This type of communication model extends the device to cloud communication type such that the data from the IoT device can be accessed by the authorized third parties. Here, devices upload their data onto the cloud, which is later accessed or analyzed by the third parties. Versus opportunities. If misconfigured and misapprehended, the IoT poses an unprecedented risk to personal data, privacy, and safety. If apprehended and protected, IoT can boost transmission, communications, delivery of services, and standard of living. IoT vulnerabilities of IoT is equal to application vulnerability plus network vulnerability plus mobile vulnerability plus cloud vulnerability. Some of the least known attacks, Sibyl attack. An attacker uses multiple forged identities to create a strong illusion of traffic congestion affecting communications between neighboring nodes and networks. Um, then SDR based attack using a software based radio communication systems. An attacker can examine the communication signal passing through the IoT network and can send spam messages to the interconnected devices. HVAC exploit HVAC, that is heating, ventilation, and air conditioning. Say, for example, searches for default users' credentials using online tools such as defpass.com. So, by logging into the default credentials, the attacker can access and hack the important devices. A rolling code attack, we all know this. Blueborn attack. Blueborn attack is performed on Bluetooth connections to gain access and take full control of the target device. Blueborn take full control of the target device. Jamming attack, we know. Hacking smart grid industrial devices. Remote access using backdoor. Attackers use social engineering skills and installs backdoor on a worker and then gain access to their LAN and then to SCADA. STR based attacks on IoT. Replay attack. The attacker obtains the specific frequency used for sharing information between connected device and captures the original data when a command is initiated by these devices. The attacker segregates the command sequence and injects it into the IoT network. Cryptanalysis attack. The attacker uses the same procedure as that followed in the replay attack along with reverse engineering of the protocol to capture the original signal. The attacker must be skilled in cryptography, communication theory, and modulation schemes to perform this attack. Reconnaissance attack. Okay, all these attacks are using SDR based attacks. So we saw replay attack using SDR based attack, cryptanalysis attack using SDR based attack. Now let's see reconnaissance attack using SDR. So this is an addition to cryptanalysis attack. In this attack, information can be obtained from devices specification. All IoT devices that run through RF signals must be certified their country's authority and then they officially disclose an analysis report of the devices. Designers often prevent this kind of analysis by obscuring any identification marks from the chipset. Therefore, the attacker makes use of the multimeters to investigate the chipset and mark out some identifications, such as ground pins, to discover the product ID and compare it with the published report. Identifying and accessing local IoT devices. Two types. A. Discovering or identifying the local IoT devices. B. Accessing the local IoT devices using DNS rebinding. So A. Discovering or identifying the local IoT devices. Attacker obtains local IP address using malicious code, uses scanning techniques like SYN scan to detect all available devices based on their response to the SYN scan. B. Accessing the local IoT devices using DNS rebinding. Next is a fault injection attack. Um, it contains optical electromagnetic fault injection (EMFI), body bias injection (BBI), power clock reset glitching, frequency voltage tampering, temperature attacks. So fault injection contains optical, uh, electromagnetic fault injection, body bias injection, power clock reset glitching, frequency voltage tampering, temperature attacks. And then Sibyl attack. Sibyl attacks in vehicular ad hoc networks, VNets, which have a greater impact on network's performance, are regarded as the most serious attacks. This type of attack impairs the potential applications in VNets by creating a strong illusion of traffic congestion. To perform this type of attack, a vehicle is declared to be present in different locations at the same time. Case study DIN attack. This was performed using a malware called Mirai. Mirai is a piece of malware that deliberately finds the IoT devices to infect them. Once infected, Mirai adds the infected IoT to a botnet. Mirai was built for the following two main purposes: find and infect other IoT devices to further grow the botnet, participate in DDoS attacks based on the commands received from a remote CNC infrastructure. So there are different stages. So in stage one, Mirai infects the device. It primarily scans for the ports, 22, which is SSH, 23 telnet, 5747, etc., that are open and can easily be configured to scan other ports. Once connected to an IoT, it attempts to log in using a list of username password combinations included in the malware, gain access, and infect the device. The infected device then scans other networks, searching for more IoT devices, and launches DDoS attacks. In stage 2, the malware tries to protect itself. It kills other processes running on the IoT device, such as SSH, Telnet, and HTTP, to prevent owner from gaining remote access to the IoT device while being infected. Rebooting the IoT device can remove the malware, but it can quickly become infected again. In stage 3, it launches attack. Mirai infected IoT devices launch different types of attack as part of the malware, like SYN flood, ACK flood, UDP flood, DNS water torture, etc. When attacking using HTTP GET floods, Mirai bots use a list of default user agents. One unique attribute of the malware is that it includes a list of known networks in the US. Mirai bots are told to avoid these networks when scanning for other vulnerable IoT devices. Next is IoT hacking methodology. Like any other methodology, it has information gathering, vulnerability scanning, launch attack, gain remote access, maintain access. So, information gathering using Shodan. Examples: webcam XP space country colon in double quotes US obtains all the webcam XP webcams present in the US. The next example is webcam XP space city colon in double quotes streets borough Obtain existing webcam XP webcams in streets, Boro City. Next, webcam XP space geo colon in double quotes the IP address. Obtains a specific webcam present at the geolocation. Oh, it's not IP address, sorry. It's position, latitude and longitude. And then additional filters used by attackers to obtain target information are net, net colon, search based on the IP address or CADR. OS colon, search based on the operating system used by the devices. Port colon, find all open ports. And then before after is another option, other filter before after. This filter provides result within a certain time frame. Information gathering using multi-ping. Multi-ping is similar to angry IP scanner, but this is for IoTs. Information gathering using FCC ID search. FCC ID contains two parts, grantee code and product ID. We can search for, once we get the FCC ID, we can get the information in the website fcc.gov/oet/ea/fcc ID. Discovering IoT devices with the default credential using IoT Seeker. For example, attackers run the following command to find devices with default credentials. Perl IoT scanner.pl, and then the, what is that? Is that IP or MAC? So this is how we can use IoT Seeker to obtain the default credentials. IoT Seeker. Vulnerability scanning using Nmap. So Nmap, we can use options dash n. Dash n is for no DNS resolution. Uh, SYN scan or stealth scan. Dash S, capital S. Dash B, capital T for TCP scan. And then the port range, and verbose scan dash V, aggressive scan dash A, OX. Target will send only XML output to the standard output when we use this small O and capital X, and then the name IP. So then to perform a complete scan of IoT device that checks for both TCP and UDP services and ports, the command is almost same, but when we specify the uh, SYN or stealth scanning, we can also give the option U. And then when given the port range also, we can give U colon 0 to 65535. All other switches remains the same. And then to identify IPv6 capabilities of a device, same as the previous column, but here we will give dash 6 as an option, which is for IPv6. Vulnerability scanning using RIoT vulnerability scanner. Retina IoT vulnerability scanner identifies at-risk IoT devices such as IP cameras, DVRs, printers, and routers. Sniffing using forensics. Sniffing using forensics. And then attackers use tools such as forensics to sniff the traffic of IoT devices. Forensics is a non-intrusive 6-low PAN network analysis tool. 6-low PAN is a medium-range wireless communication protocol. Sniffing using Wireshark. And then analyzing spectrum and IoT traffic. Analyzing spectrum using GQRX. A tool called GQRX. Analyzing spectrum using GQRX. Analyzing IoT traffic using IoT Inspector. Rolling code attack using RF crack. And then hacking Zigbee devices with Atify Zigbee framework. Most of the IoT devices use the Zigbee protocol for short-range wireless communication. Attackers find vulnerabilities in Zigbee-based IoT and smart devices and exploit them using tools like the Atify Zigbee framework. Attackers use ZB Stumbler from the Actify Zigbee framework to identify the channel used by the target device. An attacker can perform a replay attack by capturing and replaying the same packets to observe the behavior of the device. So again, I will repeat the tool name: hacking Zigbee devices with Attify Zigbee framework. Attify Zigbee framework. So in this, there is a tab called ZB Stumbler that is used to identify the channel used by the target device. Next is Blueborn attack using hack RF1. IoT devices include some sort of wireless communication using RF or Zigbee or LoRa. Attackers use hack RF1 to perform attacks such as blueborn or airborne attacks such as replay, fuzzing, and jamming. Replay attack using hack RF1. Attackers use online resources such as FCC database to determine the frequency of the target device. Attackers also use tools such as RTL SDR to determine the frequency of the target device in the vicinity. Once the frequency is determined, attackers use tools such as HackRF1 to launch a replay attack on the target device. SDR based attacks using RTL SDR and GNU radio. RTL SDR is a hardware tool. GNU radio is a software tool. Next is side channel attack using chip whisperer. Attackers use chip whisperer for performing side channel power analysis and glitching attacks. Side channel power analysis allows attackers to extract cryptographic keys from a system. Attackers use chip whisperer for breaking the implementation of complex algorithms like AES and triple DES by using power analysis attacks. Gaining remote access using telnet. And then attacks now maintain access by exploiting firmware. The firmware mod kit allows for easy deconstruction and reconstruction of firmware images for various embedded devices. Firmware analysis and reverse engineering. Firmware acts as the central point in controlling various IoT devices. Attackers analyze the firmware of the target IoT devices to uncover the underlying loopholes and vulnerabilities. Attackers perform analysis to identify the passwords, API tokens, and endpoints, vulnerable services running, backdoor accounts, configuration files in use, private keys, stored data, etc. IoT hacking tools. Um, so, information gathering tools. We have Census.io and Thinkful.net. Census and Thinkful. Sniffing tools, SUPHACAP, SUPHACAP. Vulnerability scanning tools, Bstorm, Metasploit Pro, IoT Inspector, Bitdefender. So these are vulnerability scanning tools. Tools to perform SDR based attacks, Universal Radio Hacker, GQRX. IoT hacking tools, Firm Analyzer enables device vendors and security professionals to perform an automated security assessment of the software that powers IoT devices firmware to identify configuration and application vulnerabilities. This tool notifies users about the vulnerabilities discovered and assists in mitigating those in timely manner. Firm Analyzer. Next, measures. Disable Telnet port 23. Locate control system networks and devices behind firewalls and isolate them from the business network. So the control system networks and the related devices should be behind the firewalls. Disable the UPnP port on routers. Monitor traffic on port 48101 as infected devices attempt to spread malicious file using port 48101. So monitor traffic on port 48101. Next, IoT security tools, ccat.io, DigiCert IoT security solutions. So ccat.io and DigiCert IoT security solutions are the security tools. Next, CCAT.io is a security first SaaS technology to operate IoT products in a reliable, scalable, and secure manner. Digi's at home and consumer IoT security solutions protect private data and home networks while preventing unauthorized access to PKI based security solutions for consumer IoT devices.